Hi everyone, this is lesson 3 in our Roots and Powers unit. This is section 4.4 in the textbook, and the title of the lesson is Fractional Exponents and Radicals. So we are going to connect exponents and radicals today. They actually are the same thing. We just use different notation to mean the exact same calculation. So we're going to kind of link these two topics today. Exponents, so first I will start with reminding you to watch this YouTube video if you would like to. I think it's a really good video to kind of explain intuitively how fractional exponents work. It goes all the way up to logarithms, which is a topic you won't see until grade 12. But if you watch sort of the first 2/3 of that video, I think it really explains how exponents work and how radicals work in a nice way. But we are going to start here with some notation. So if I have a fraction as an exponent, so quick example, 4 to the power of 1/2. What that's actually the same as is it's kind of like what's half the number in a kind of multiplying way. So if I was going to multiply by 4, multiply to get to 4, what would get me halfway there? So another way of asking that is just what's the square root of 4? Okay, square roots actually, if you didn't know this, you can put a little 2 here as the index, but we've kind of dropped that 2 over time, but there is a kind of a hidden 2 there. So the answer to this would just be 2. Okay. 8 to the power of 1/3, it's kind of asking, or it is asking, if you were going to try to multiply to get to 8, what would get you 1/3 of the way there? So like 8 is made of 3 2's, 2 times 2 times 2, so 1/3 of the way there would be 2. It's the same thing as asking what's the cube root of 8? It would be 2, since 2 times 2 times 2 is 8. 2 is sort of 1/3 of the way there. So we're going to practice using this notation today, converting it to a radical and then answering the question. Okay. We're going to try to do all these questions without our calculator. Okay, first example, 25 to the power of 1/2. First, we're going to convert it to a radical. So it means the same thing as square root 25. Now, again, you can put the little 2 there or you can leave it out. It means the same thing. So we're looking for two numbers that multiply to 25. So 5 times 5 is 25. Okay. And if you like this other way of thinking, I kind of like this. So feel free to use it if you like. 25 is 5 times 5. So what this notation of half means is kind of like if we're multiplying to get to 25, what's halfway there? Half of these 5s. So that's the answer. Okay. All right. Negative 27 to the power of 1/3. So that is the same as asking what is the cube root of negative 27? If you were to break negative 27 up into 3 parts, what is one of them? So since 27, or negative 27, is negative 3 times negative 3 times negative 3, you need 3 negative 3's to get to negative 27. This answer would be negative 3. I forgot to circle this number. There we go. Okay, so 1/3 of the way there would be one of those negative 3's. Okay, next one. So in this chapter, whenever we see decimals, I'm going to put a little star here. Best thing to do is convert them to fractions, because all of our rules will have all deal with fractions and not the decimal versions of those numbers. So 0.25 is 1/4. So this is the same as 16 to the power of 1/4. And so this would be the same as the 4th root of 16. So we're trying to break up 16 into 4 parts. Oops. So 16 is actually equal to 2 times 2 times 2 times 2, 4 2's. So the answer would be 2. Okay, it's 1/4 of the way to 16 is 2. Okay, and very last one, you can try on your own. Pause the video and then try it. I'll just do it on my screen here. This is 144 to the half. So it's the square root of 144, which is 12. halfway to 144 in a multiplying sort of way is 12. Okay, so that's fractional exponents. And notice with those ones, the numerator for all of those ones was 1. We're going to add one more layer of complexity in the next level where our numerator is not 1. Now it's a number. And all we do with that number is actually just stick it on the outside. So I'll show you what I mean. It's just going to become our power. Okay, it can go inside the square root or it can go outside the square root. The number down here still goes to the index of the root or the radical. Okay. So let's practice writing these as radicals and then answering them. And again, we're going to try not to use our calculator at all here. Okay, 25 to the power of 3 over 2. So this is the same as, so the 2 becomes the index of our radical. So it's going to be a square root. And then the 3 becomes the power. Okay, so sometimes people like to remember it as like roots in the ground, powers up top. Like, you know how plants have roots in the ground? So roots go on the bottom, powers up top. Okay, so let's answer this. We're going to answer inside the brackets first. Square root of 25 is 5. Now we're going to answer the power of 3 part. So this is going to be 125 because 5 times 5 times 5 is 125. Okay, let's do the next one. So again, roots on the bottom, powers up top. So this is going to be the same as cube root of negative 27. Again, roots on the bottom, powers up top, all to the power of 4. So we answer inside the brackets first. Cube root of negative 27, we actually did it up top there. It is negative 3, and we're doing negative 3 to the power of 4. So we multiply 4 negative 3's together and we get positive 81. All the negatives cancel out when you multiply an even number of them. And so we get 81 as our answer. Okay, this one here, we have a decimal, and my tip before, I'm going to say it again, we want to change all our decimals to fractions today. So 0.75 is actually the same as 3 over 4. So again, we're going to do roots on the bottom, powers up top. So roots at the bottom, powers up top. So we get, so the fourth root of 16, we actually did it up top there. It's 2, and we're doing that to the power of 3, so it would be 8. 2 times 2 times 2 is 8. Okay, last one, again, decimals to fractions. 1.5 is 1.5. 1.5 can be converted to 3 over 2. 1.5 equals 3 over 2. It's the same number, so that's our fraction. Roots at the bottom, powers up top. Okay, so it becomes square root of 100 all to the power of 3. So that is 10 to the power of 3, which is 1,000. Okay, so all of those should be able to be done without a calculator, but of course you should be able to check with your calculator as well. But I need to see your reasoning when you're doing questions like this. Okay, I'm just realizing I forgot to highlight some of the numbers here. Okay, there we go. Last one's a word problem, and we're going to need to use BEDMAS for this one. Let's have a look. So it says biologists use the formula B equals 0.01 times m to the power of 2/3. So here's our little formula we'll be using to estimate the brain mass in kilograms of a mammal with body mass m kilograms. Estimate the brain mass of the following mammals using the formula. So first we're going to do a dog. Maybe we can do that one together, and then you guys can try the elephant. Okay, so we're figuring out their brain mass, and we're going to use this formula, and we're going to plug in the number they give us. So here they give us the body mass to be 27. So the m is going to be replaced in the equation with 27. So we'll have 27 to the power of 2/3. Okay, we do have to follow BEDMAS here. So we're going to be evaluating the exponent first, and then we're going to be multiplying. So let's convert that exponent to a root. Remember, roots at the bottom, powers up top. So this is the same as 0.01, And then we'll do the cube root of 27 all to the power of 2. Again, we're going to be evaluating that exponent first and then multiplying by 0.01. The most common mistake students make with these is they try and multiply first, but we do always need to follow BEDMAS in math, the order of operations. Okay, so 0.01 times. So the cube root of 27 is 3, and then 3 squared is 9. So I'll just write that in 2 steps. So we answer inside the brackets first. And finally, we get 0.09 as our final answer, and the answer is in kilograms. So the brain mass of a dog is approximately 0.09 kilograms. Okay, a dog with body mass of 27 anyways. Let's do an elephant with a body mass of 1,000. You guys can pause the video here and try this on your own. I really recommend you do that, but I will do it quickly on this side. So we're going to replace the m with 1,000 this time. First, we'll convert it to a radical. Roots on the bottom, powers up top. So it's 0.01 times 10 squared. We have to evaluate the exponent first. 0.01 times 100, and so it's 1 kilogram. Okay, that's it. That's the end of the lesson.